Okay. Number 18, f of x equals x squared 7x plus 12. Okay. S for the zeros, y-intercept, x-intercept. And that problem is really screwed up. Oh, never mind. It didn't ask you for that. That was 17. Okay. 10, sketch a reasonable graph. Now, this is actually kind of a capstone problem. If you can do this, you're good, about for the first at least 3 weeks, maybe month of the course. Okay. Yeah, of course, there are other things. There are things that you won't be all that familiar with. But it's a really good head start, and it shows you a lot of what pre-calculus is all about. Okay. So anyhow, with this one, the quadratic formula, well, what's the quadratic formula say? It says ax squared plus bx plus c equals 0. If and only if x is one of these values. Okay. Now this says if x is one of these values, then that function is going to be 0. Okay. And it isn't 0 anywhere else. 0 only for these values, and only for these values. That's what if and only if means. That's worth thinking about. Okay. It's worth understanding that formula. So zeros are when f of x equals 0. Okay. F of x equals x squared plus 7x plus 12. So f of x equals 0. IFF stands for if and only if x squared plus 7x plus 12 equals 0. Okay. So that's the number one thing you need to understand about the quadratic formula. Now, there is an assignment on the quadratic formula. A lot of you didn't do it. It'd be worth doing. Okay. I don't care if it's late. I mean, do it, yeah, late assignment thing. But that's it. Now, the solutions by the quadratic formula, x equals -7 plus or minus the square root of 7 squared minus 4 times 1 times 12. All that divided by 2 times 1. Now we've gone over the quadratic formula. Just to remind you, a is the number in front of x squared. In this case, there's implicitly a 1 in front of x squared. How many x squared you got? B is the number in front of x, that's 7. So 7 goes where B is, here and here. There it is. Okay. And C is the number that doesn't have an x on it. And that just goes here. Okay. And A is 1, so it goes here and here. So there it is, and there it is. Okay, well, that simplifies, and you can do the arithmetic as well as I can. probably better if you got calculators. Okay, but that's going to be 49 minus 144, which is negative 95. Over 2. Well, that equals negative 7 over 2 plus or minus the square root of 95 times I over 2. Remember that I is the square root of negative 1. You know, we did have a assignment of complex numbers, right? Okay, I think we did. I could be confused with the other course. But the point is, this is not a real number. Okay, there's no real number that's the square root of 95, negative 95. There's no number that you can square to get negative 95. It's not a real number. Since the square root of negative 95 isn't real. So there are no x intercepts. So basically, if the quadratic formula ends up with a negative under this radical, you're not going to have any x-intercepts when you graph this thing. Okay? Now, a little more. Okay, y-intercept. Now, we saw it with linear graphs, and we did it with graphing linear functions when we did the simultaneous equations and elsewhere. The y-intercept occurs.
Ella, is there anything else to carry? I think she went up. I'm sorry, Ella, but
And that's equal 0. Okay, just like the x-intercepts occur when y equals 0. So that's an important thing to try to remember, because again, if you remember it, it comes up again and again and again in pre-calculus. Okay. Y-intercepts occur when x equals 0, and x-intercepts occur when y equals 0. Okay, well, if x equals 0, then since the function is f of x, y is f of 0. Of course, f of 0 is what you get when you replace x by 0. So that's 12. Okay, well, now we have something to put on our graph. We have a point here that we'll call 0, 12. Now, if the quadratic formula had given us zeros here, then we'd have points to put on the x-axis, which is where y equals 0. I'll modify slightly to show you how that works. If I replace this plus 12 by a negative 12, then it comes out with 2 x-intercepts. But in this case, you don't have x-intercepts because f of x can't be 0 because of what the quadratic formula tells you. Okay. Now, there's something else I should have asked for on this thing. Yeah, the axis of symmetry. I got distracted by that max thing and forgot to write down axis of symmetry. Okay, well, the axis of symmetry remember your quadratic formula. Okay, this could equal negative b over 2a plus or minus the square root of b squared minus 4ac divided by 2a by the distributive law, because dividing by 2a is the same as multiplying by 1 over 2a. So multiplication by 1 over 2a would certainly distribute over the plus or the minus, okay? So division does too, okay? Whether you totally understand that or not, I want to give you the reason. The negative b over 2a, which is here, is going to be halfway between negative b over 2a plus something and negative b over 2a minus the same thing. Okay? Negative b over 2a plus this is going to be that part of the right of negative b over 2a. Negative b over 2a minus that thing is going to be that far to the left. So here's the payoff. The axis of symmetry is real easy to remember if you remember the quadratic formula. Whether you understand the rules or the reasons, axis of symmetry occurs at x equals negative b over 2a. For this function, b is what's in front of x, that's 7, and a is 1. Okay, so whether you understand all the explanation or not, you can understand the rule that you just take the negative b over 2a out of the quadratic formula, gives you the axis of symmetry, and that's a big deal. Because the axis of symmetry then is the graph. Well, if you go here to x equals negative 7/2, there's your axis of symmetry. Okay? This is the axis of symmetry. X equals negative 7/2. What's the value of the function here? Okay, let's stop and talk about this for a minute. Okay, interestingly, and I got called on this. Somebody factored this thing and seemed to contradict the quadratic formula. No, it didn't contradict the quadratic formula. It contradicted the bonehead up here in front of class. Because if I do minus 4 times 1 times 7, no, wait a minute. Yeah, it didn't. What's going on here? It can't be. Okay, there's nothing wrong with what I wrote here. Minus 4ac, oh, 4 times 1 times 12. I use 12 squared. Don't ask me, because I don't have a good answer for you. How in the world I did that? Because, you know, I felt like my brain was halfway working this morning. Okay, well, actually, I like this better. Okay, I like this better because 4 times 12 is 48, isn't it? It's not 144.
Yeah, it's 48.
I had the square floating around in my head. When I saw the 12, I automatically squared it. Didn't bother multiplying it by 4 or anything. That's how I got negative 95, okay?
So when
And that's totally wrong. And when I looked at this, I thought, well, 12 is kind of big. That's going to make it negative, but it doesn't quite, okay? This gives you 4. 49 minus, no, it doesn't. It gives you 1. It's getting scary. Okay. So we got 1 here. All right. Now I thought that, you know, toward the end of the course, I'd make a mistake for change. I never make mistakes, right? Nobody's agreeing with me. You're right. Okay. So what I wrote here would have been correct if that was really supposed to be negative 95. There would be no x-intercepts. However, this is going to be equal to negative 7/2 plus or minus the square root of 1. How many can you hold up fingers and show me what the square root of 1 is? Just to make sure I don't screw this. Very good. Thank you. Okay. So all that reasoning is out the window. But remember that reasoning, because it occurs. If this number was just a little bit bigger, you know, notice that your 7 squared minus 4 times 1 times 12 was set 49 minus 48. If 12 had been just a hair bigger, you'd have had a negative under here and that reasoning would have helped. Okay? That tells me something else. Tells me that the vertex is going to be just a little bit below the axis here, but well, negative 7/2 plus or minus 1/2 is negative 3 or negative 4. Negative 7/2 plus 1/2 would be negative 6/2, which is negative 3. Negative 7/2 minus 1/2 would be negative 8/2, which is negative 4. So and this is exactly what at least one of you got when you factored. Okay, and I'm glad that, you know, this is the person who commented a little earlier when we started this course, hated factoring. Now I don't know if he's beginning to love it, but he's at least comfortable with it and used it to show me that I was wrong here. Okay, so many thanks. Okay, anyhow, feather in your cap. Okay. Okay, so there are the zeros. So these points are on the graph. Yeah, so we put them down here. Now, first place, this isn't negative 7/2 anymore. This is negative 3. And let's correct it. Actually, symmetry is still negative 7/2. But if there's 7/2, well, that means negative 3 is about here, negative 4 is about here, negative 2 is here, negative 1. I don't have that ruled off very well, but we get the idea. Okay, so we have the point negative 3, 0, and negative 4, 0. And let me color code those. So this point's on the graph, this point's on the graph, and this point's on the graph. Now, the other thing is, any quadratic function has a graph that looks just like the basic squaring function. It's a parabola. So okay, graphs out of a basic squaring function, which is, I say, that is a parabola, and this thing has refocused itself, so, or resumed itself. And I guess it's in focus now, i.e. every graph has a graph in the shape of a parabola, i.e. The shape of that basic squaring function, which is a parabola. Now take a minute, because this is worth it. We got 3 points on the graph of this thing, and it's got a parabolic shape. Sketch that for me, and sketch the parabola. I'm not asking for a completely accurate parabola. It's kind of hard to, went the wrong way. But there we go. Okay, not asking for a completely beautiful, wonderful parabola like the one I'm going to draw. Okay, I'm committing myself. Okay, but you draw a parabola. Okay, so get that on your graph. Then we'll say a couple more things and we'll move on to other problems. This is really kind of the biggie. Let me say all that for everybody. The question came up, what's the significance of that 12? Okay, well, if x equals 0, y equals 12. Okay, that means if you're making a table for this thing and 0 was one of your x values, the y value would be 12, and that would give you the point 0, 12. Okay, then I commented, you don't want to graph a parabola by making a table, because you're probably going to miss the vertex. Okay, just any old quadratic function, the vertex might be way out there. And if your table doesn't include points near the vertex, you're just going to get something that looks like a straight line with huge values. It's not going to look like a parabola. Okay, that's well worth understanding. Because even in my pre-calculus class, sometimes I see people try to make a table to graph a parabola. We don't do that. Okay, not in pre-calculus. We've made tables for the basic functions. Now, there's another thing I can say about how the basic function relates to this, but I'm going to save that. Okay, so hopefully I answered the question about, what's the significance of that 12? It's just x is 0, y is 12, so the point 0, 12 is on the graph, and that's your y-intercept. So now again, this thing's going to be a parabola. It's got to go through these 3 points. So go ahead and sketch the graph, as you probably already have. Let me walk around and see. Okay, now there's more to be said here, but let's go ahead and get this graph. The graph has to go through this point, this point, and this point. And it's got to have the shape of the squaring function. So the graph is going to kind of do this. So if I come down through here and hit this point, come back up through here. Well, it got a little sloppy here because I was trying to dodge the corner of this board, but actually didn't turn out too bad. Okay, should be a little more symmetric. I should have, and I was trying to go over just a little further on this side because this side's a little closer to the axis of symmetry than this one is. Okay, in a perfect parabola, and as this graph would be, you'd have a little better symmetry. This is a little lopsided. Okay. This would be just like the graph of the x squared function, shape-wise, if the y-axis was the axis of symmetry. Okay? Now I'm going to say something else that you don't need to know for this course, but if you use this as kind of a quick review before you start pre-calculus, or come back to it, even if you're taking pre-calculus, this is kind of a big deal in pre-calculus. If you take the x squared graph, which would have vertex here and go through 1, 1 and 2, 4, right? So that graph, if you take that graph and move it over here and move it down a little bit, you get this graph. And that whole process of how you move a graph around, you take a basic graph and you move it, okay? That's called transformations, and you see that in the very first chapter of pre-calculus. We're not going to have time to go over transformations in this course, but this is an example of a transformation. So if you have the y equals x squared graph, Okay. And use a different color. And the y equals x squared graph here. You move it over and move it down a little bit. So you can take that basic function, move it over and down just a little bit, and you get the f of x graph. Okay, and that's two transformations. You call it horizontal shift and vertical shift. There's much more to transformations, and again, we're not going to address that in this course. We just don't have time. But this is enough. Okay, so you understand the quadratic formulas are going to be really important in pre-calculus. There's much more I could say about it, but that's enough for right now. It should give you an introduction that might be useful to you later. I'll say it here. What we did here to get this solution is what we would do for problem 14, except you'd have different numbers here. Okay, problem 14, I think on yours is x squared minus 8x plus 17 equals 0. I'll also comment, you might make yourself a note, you ought to work that out. You're going to get a negative under the radical for that one, because the 17 is really big, and the 17 is your c. So you're going to have a big negative here, along with b squared. So everything I said about what happens with the negative applies to that one. I'll also say, worth noting, the graph of number 14, if we use the formula for number 14, which is x squared, you'd have a minus 8x, but then a plus 17 here. You get your axis of symmetry. Very easy. It would be 4, because negative b over 2a would be 4. The axis of symmetry would be over here, but the whole graph would be above or below the x-axis because it doesn't go through the x-axis. Okay, so that much is worth understanding about problem 14. But the problem only asks, and if it came out on the test, I wouldn't ask you to do a graph. I just ask you to do this. Okay, this type of calculation will be a complete answer to number 14. Okay, there are some question on number 3. At least one person gave that one a 3, but it's very straightforward. It reviews the rules for multiplication of fractions. If you multiply fractions, you multiply the numerators and you multiply the denominators. So this is 1 times 1 over x minus 2 times x minus 5. Okay. Now I would, if you want to write 1 over x minus 2 times x minus 5, I would consider that a satisfactory answer. It's even better if you use the distributive law and show it both ways, factored and unfactored. So you recognize this as a quadratic expression. Okay. 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 Somebody pointed out that number 3 was adding, and yeah, I can see now that it's adding. I probably picked up the multiplication in my peripheral vision because that's on the next problem. So now this is number 4, but the numbers aren't exactly the same. Number 4, you'd have an x plus 2 and an x plus 3, but it's obvious what you would do with that. So nobody's going to have any trouble with that. Okay, number 3 was 1 over x minus 2, x plus 2. Well, I can't read those, plus 1 over x plus 3. Well, I'm going to do this in a column. We need a common denominator. And I really want you to, include this step where you see that we're multiplying this by whatever it takes to make the denominator the same as the denominator we're going to get here. And that's going to be accomplished if your common denominator is x plus 2 times x plus 3. So here the denominator is now going to be x plus 2 times x plus 3. And of course, when I multiply by something, I don't want to change the value of this thing, so I got to multiply by something that's equal to 1. And x plus 3 over x plus 3 is clearly equal to 1. Well, I can do the same thing over here. Multiplying by x plus 2 over x plus 2. So now I have x plus 3 over x plus 2 times x plus 3 plus x plus 2 over x plus 3 times x plus 2. And of course, doesn't matter what order the x plus 3 and x plus 2 are in. These denominators are the same. So that would then be x plus 3 plus x plus 2 over x plus 2 times x plus 3. Then I can add these. I get 2x plus 5 over x plus 2 times x plus 3. And as I've said, it's good to keep this factor until you see if you have something in the numerator that also factors, and maybe one of those factors matches one of these and you can simplify it. Okay? That's not the case here. That's not going to factor. So you could then, and it wouldn't be required. I'm okay if you leave the denominator factor because I know that you can use the distributive law to multiply the x plus 2 by the x plus 3 and get this, okay? So I want to see this. And if I also see this, well, that's nice, okay? So now I've reversed the numbers. I've reversed the fractions for number 3 and number 4. So yeah, number 3 would really be this plus this, and number 4 would really be this times this, but the principle's clear. And everybody did pretty well with this. We did it earlier in the course. All right. Okay, now we probably I haven't given this stuff in type form until today. SQRT stands for the square root. Again, if you're typing into a computer algebra system, you would type SQRT, parentheses, etc., right? So that means that's okay. I'm just writing this out the way you would type it into a computer algebra system. Just to show you how that looks, because you might well run into it. You type the 1, you generally have to type your operator, which for multiplication would be the asterisk, okay? And then it'd be x to the 1 times y to the 6th. By the order of operations, y is raised to the 6th power. Nothing else is. Okay, because you have a multiplication here. You do the exponents first. This gives you the y to the 6th. This gives you the x to the 1. This gives you the 1. Well, you're not going to be required to use computer notation, but it's worth just saying. Okay. And since I've still got 2 minutes, that's all it's going to take. Okay. So this means Means this, which is just the square root of x, y to the sixth, okay? So square root of x, y to the sixth is the square root of x times the square root of y to the sixth. Now, what's the square root of y to the sixth? Okay, now we did work with radicals, okay? And I think this is probably a fair question, but if an unfair question occurs on your exam, do it anyway if you can. There's no risk. It's an unfair question, you get credit if it helps your grade, and I ignore it otherwise, okay? So, and then, yeah, I go back and determine, I kind of think this is a fair question, okay? But anyhow, the square root of y to the sixth is what? Well, so somebody said, well, it's y to the third. So let's be sure we understand why that is y to the third. If we write 3, we get this done here. So I'll write this down here, and hopefully we understand this. So this is the square root of x times y to the third. We usually write that y to the third square root of x. I'm not picky about that in this course, okay? Okay,